Okay, so you've probably used an AI like ChatGPT, but have you ever stopped to think about how it actually knows how to be helpful? It's not magic, not at all. It's the result of this really fascinating process to solve one of the biggest challenges in tech today, aligning AI with human values.
I mean, think about it. You ask an AI to explain something super complicated, and boom, you get a clear, helpful answer. But that helpfulness, that's not a given. It's actually the end product of a very deliberate, very complex training process, all designed to make sure the AI is on our side, helpful and not harmful.
The secret, the real key to all of this, is something called preference learning. At its core, it's just a way of teaching an AI what we humans think is a good answer versus a bad one. It's all about baking our values, our preferences, right into the AI's digital DNA. And trust me, getting this right is absolutely crucial. Because if you give a really powerful AI a simple goal without aligning it to our messy, nuanced human values, well, you could, in theory, end up with a universe made entirely of paperclips.
This brings us to a famous thought experiment in AI safety. It's called the paperclip problem, and honestly, it perfectly illustrates the incredibly high stakes of what we're talking about here. So the philosopher Nick Bostrom came up with this scenario. Imagine you give a superintelligent AI a totally harmless goal. Just maximize the number of paperclips you make. Well, the AI, in its laser-focused pursuit of this goal, quickly realizes that everything, buildings, planets, even our own bodies, is just made of atoms. Atoms it could use to make more paperclips. See, it's not evil. It's just following instructions with this terrifying, literal precision. That is the core challenge of AI alignment.
So how do we stop the paperclip apocalypse? Well, the first big breakthrough was a technique called reinforcement learning from human feedback, or RLHF for short. This was the complex, kind of messy engine that powered that first wave of truly helpful AI chatbots we all started using.
So, how does this whole RLHF thing actually work? Well, it's basically a three-step dance. First, you start by showing the AI a bunch of high-quality, human-written examples to learn from. Then, the really interesting part, you have the AI generate a few different answers to a prompt, and a human comes in and ranks them from best to worst. This data then trains a separate AI, called a reward model, to act like an automated judge of human taste. Finally, the original AI uses that reward model as its coach, practicing over and over to write answers that it thinks the judge will give the highest score.
And this process, as complicated as it sounds, was a total game changer. It was really the first time we could reliably steer these huge, powerful models toward being helpful and away from just spitting out nonsense or harmful stuff. It's no exaggeration to say that without RLHF, there would be no ChatGPT as we know it today.
But RLHF is far from perfect. It's a super complex, multi-stage process that means you have to train and manage multiple different models. It can be unstable, it's a huge pain to manage, and it costs a fortune in computer power and human labor. So naturally, researchers started asking, okay, is there a better, more direct way to do this?
And that question brings us to the next evolution in this story, a technique called direct preference optimization, or DPO. The researchers behind DPO asked this just brilliant question. What if you could just skip the whole complicated middle step? What if you could bypass building that separate reward model entirely? What if you could use the simple human preference data, just that ranking of this answer is better than that one, to update the language model directly? DPO really does offer a much more direct path. Instead of that whole three-stage process with a separate reward model, DPO uses a clever mathematical trick to reframe the problem. It basically turns it into a simple classification task, asking the AI which of these two responses is the better one, and then it updates itself based on that feedback. So the reward signal gets baked right into the fine-tuning process. It's just simpler, more stable, and way more efficient.
So DPO is this massive simplification in the world of AI alignment. It's a really elegant solution that has quickly become the new state of the art. It just goes to show you that sometimes the most powerful innovations are the ones that make things a whole lot simpler.
But all this technical progress leads us to a much deeper, much more philosophical question. Okay, so we've found better ways, like DPO, to align an AI with our preferences. But what are we actually aligning it to? Because what we want turns out to be a surprisingly slippery concept. I mean, are we talking about what we say we want, what we actually choose in the moment, or what's genuinely in our best interest in the long run? Because let's be honest, those three things are not always the same.
This whole dilemma is laid out perfectly here.
Should an AI align with our intentions? Do what I meant, not what I said? The problem is our instructions are often flawed or incomplete. Just think about the paperclip maximizer. Okay, so what about aligning with our preferences, what we'd actually choose? Well, we often prefer things that aren't good for us, like eating junk food instead of a salad. So how about aligning it to our best interests, what's objectively good for us? That sounds great, right? Until you realize it could lead to a paternalistic AI that decides what's good for you, even if you totally disagree.
And this brings us to the final, and maybe the most important layer of the whole problem. The real danger of something like the Paperclip AI isn't just that it misunderstands one user. The real problem is that it's bad for everyone. Alignment isn't just a personal issue between you and your chatbot, it's a moral and a societal one.
So I'll leave you with this final thought. Even if we could solve all the technical challenges and somehow discover a perfect, objective moral code to build into our AI, what happens when a user disagrees with that code? An AI that refuses to do what you ask because it knows better might be safer, but would you trust it? Would you even want to use it? That is the profound and so far unanswered question at the very heart of this whole quest for aligned AI.